Hi friends, once again KTSir is here from the channel Karthik Tuitions. In this video, we are going to talk about a new concept from the chapter circle. So let's start with today's video. Now today we are going to talk about angle between tangent and secant. Sir, iska matlab. Let's have a look at a figure. I have a circle. I take a point B on the circle. Now I draw the ray BC, which is a tangent to the circle. Now I draw BA, but A is a point which lies on the circle. So in other words, I get an angle ABC. Now if you observe carefully for this angle, point B is a vertex on the circle. Ray BC is the tangent of the circle and ray BA is a secant of the circle. The combination of all these 3 points gives us the angle between tangent and secant. Okay, let's proceed further. Now see, again I take a circle where AB is my diameter. Sir, आपको कैसे पता? See, it is passing through the center O. Now I draw the tangent to the circle at point B. So BC is my tangent. Now if you try to recollect tangent theorem, at a point of contact, the angle has to be 90 degrees. So here our angle B is 90 degrees. Now angle ABC is our angle between tangent and secant. Now if you observe angle ABC as an intercepted arc, to make it clear understanding, I'll take one point on the arc AB. So now for angle ABC, arc ADC is our intercepted arc. Now what is the measure of arc ADB? See, it is a semicircle arc and the measure of semicircle arc is how much? 180 degrees. So the measure of arc ADB is our 180. What is the angle ABC? It is 90 degrees. What do you observe? You observe that angle ABC is half the measure arc ADB. So in other words, I can say angle between tangent and secant is half of its intercepted arc. Now this is nothing else but theorem of angle between tangent and secant. Theorem of angle between tangent and secant. Now let's have a look at a proper statement from the beginning. The statement will go as the measure of the angle between tangent and secant is half the measure of its intercepted arc. Now if you observe our angle ABC, where B is the vertex on the circle, BC is a tangent and BA is a secant. Hence, it is the angle between tangent and secant. So the measure angle ABC has to be half the measure of its intercepted arc, that is arc AXB. I hope you have understood this theorem. Now, there is one more concept which is bit ahead of this concept. So let's get back to that. Now see, I have taken the same figure of the earlier slide. Angle ABC is a tangent secant angle. So it is half the measure of its intercepted arc. What is the intercepted arc of angle ABC? It is AXB. Kahani mein twist. I take a point P on the circle and I join it with A and B. So now if you observe, my angle APB is the angle formed on the circle. So it is my inscribed angle. Now if this is an inscribed angle, then which is the intercepted arc for APB? It is AXB. So in other words, I can write measure angle APB is equals to half the measure arc AXB, and the reason is inscribed angle theorem. Now observe the right hand side of both the statements. They are equal. So in other words, I can say measure angle ABC is equals to measure angle APB. In other words, angle ABC is congruent to angle AP. Now this concept is known as angles in alternate segments. In ICSE board, this concept is termed as angles in alternate segments, whereas in state board, it is termed as same theorem of angle between tangent and segment. Let's look at a statement. The angle between a tangent of a circle and a chord drawn from the point of a contact is congruent to the angle inscribed in the arc opposite to the arc intercepted by the angle. So state board students can remember this concept as theorem of angle between tangent and secant, and for ICSE board students this is angles in alternate segment. Only the titles are different, concepts are same. I have taken two sums based on a same concept. So let's start with the sums now. Two circles intersect each other in a point R and point S. Line PQ is a common tangent touching the circle at point P and Q. Prove that angle PRQ plus angle PSQ is equals to 180 degree. Sir, कुछ समझा नहीं. Let us start. We'll get it. Now PRQ and PSQ. So first, to get a relation between these two angles, that is a small construction. Let's draw segment SR. सर इससे क्या होगा? इससे बहुत कुछ होने वाला है. Now observe angle PSR. Now PSR is your inscribed angle. Now which is the intercepted arc for PSR? It is RPR. Same way, if you observe angle RPQ, it is the angle between tangent and secant, and the intercepted arc for the angle is again PR. So in other words, I can say angle PSR is nothing else but congruent to angle RPQ. Do you all agree? And the reason is angles in alternate segment. चलो थोड़ा बाजू में देखो. Again, if you observe the angle QSR, it is an inscribed angle, and its intercepted arc is RQR. Now, if I talk about angle RQP, it is the angle between tangent and secant, and its intercepted arc is also RQR. So, in other words, I can say angle QSR is congruent to angle RQP, and the reason is same, again angles in alternate segment. Now, let's talk about triangle PRQ. Now see, in triangle PRQ, if we add all the three angles, what the total should be? 180 degree. When I say three angles, I am talking about angle PRQ plus angle RPQ plus angle RQP is equals to 180 degree. And the reason is angle sum property of a triangle. Now, if you observe, RPQ is congruent to PSR. So in the next step, instead of writing angle RPQ, I'll write it as angle PSR. And angle RQP is congruent to angle QSR. So I'll replace it with angle QSR. That also is equals to 180 degree. Now, PRQ angle will remain as it is. But if you observe the figure, PSR plus angle QRS becomes angle PSQ. And the reason is angle addition property. If you observe, we have got what we are supposed to prove. That is angle PRQ plus angle PSQ is equals to 180 degree. I hope you understood this sum. Let's move to one more such sum. Two circles intersect each other at points A and E. Their common secant through E intersect the circles at point B and D. The tangents of the circle at points B and D intersect each other at point C. Prove that quadrilateral ABCD is a cyclic. Now see, to prove any quadrilateral is cyclic, we were just supposed to prove that opposite angles are supplement. Now when I say opposite angles, I am talking about angle A and C or angle B and angle D. Now observe the figure. If I talk about angle BAE, now BAE is your inscribed angle and its intercepted arc is BE. Same way, if I talk about angle EBC, it is a angle between tangent and secant, and its intercepted arc is BE. So in other words, these two angles are congruent. So I can write angle EAB is congruent to angle DBC. Instead of writing EBC, I am writing as angle DBC. Because the points are collinear, so definitely I can write this. And the reason is angles in alternate segments, or state board students can write it as theorem of angle between tangent and secant. Same way, let's have a look at the next angle. Angle EAD, it is an inscribed angle and its intercepted arc is ED. And if I talk about angle EDC, that is the angle formed by the tangent and secant and its intercepted arc is ED. So in other words, these two angles will also be congruent. So I get angle EAD congruent to angle BDC. And the reason is same. Either you can write it as angles in alternate segments, or you can write theorem of angle between tangent and secant. Now let's talk about triangle BCD. Now let's add all the three angles of triangle. So in triangle BCD, angle BCD plus angle CBD plus angle CDB is equals to 180 degree. That is angle sum property of a triangle. Now BCD will remain as it is, but instead of DBC, I can write angle BAE. Sir, kaise? Statement 1. Same way, instead of BDC, I can write as angle EAD. कैसे? Statement 2. Now observe the figure. When I add angle BAE and angle EAD, it becomes angle BAD. Why? Angle addition property, and the total will end up to 180 degree. Now observe the quadrilateral ABCD. We have managed to prove opposite angles are supplementary. Now in any quadrilateral, if opposite angles are supplementary, then we can say it's a cyclic quadrilateral, and the reason is converse of cyclic quadrilateral theorem. In my previous videos, I have discussed about the cyclic quadrilateral theorem. So in case you have missed that video, you can check out my playlist. I hope you have understood this sum also. If you find my video useful, please share it with your friends and do write your comments. Also like, share and subscribe my channel for the regular updates. Thank you.